This lesson is on expanded notation. It follows the lesson on place value as well as standard and literal notation. In this first slide here, you'll notice that I've given you a powers of 10 chart, and you're probably wondering what that means. The first thing I want to point out, though, is this powers of 10 chart covers the 4 notations you will be learning in class, and you would already know numerical because it's the same thing as standard and literal, which we did in the last lesson. Today, in this lesson, though, we are going to be focusing on exponential, also known as expanded notation. The reason why we need to know the powers of 10 is because when we expand our numbers, we are going to need to multiply them by powers of 10. So by now, you should be familiar with what an exponent is, but we'll talk about that more in another lesson. In this case, I just want you to see that each number in a power of 10 corresponds to a number with zeros in them that you are also probably familiar with seeing. So if we focus on, say, the number 1, the number 1 is actually the same thing as 10 to the power of 0, because as you will know, or as you may have heard, anything to the power of 0 is equal to 1. And if we continue on here, 10 to the power of 1, well, that's just 10 one time. So that's 10. And then 10 to the power of 2, well, that's 10 times 10, which is 100. So what a lot of my students tell me is that when you are looking to see what exactly this exponent 1 means, it actually corresponds to the number of zeros there are after a 1 in the number. So 10 to the power of 1, 1 means there's 1 0 after the 1, so it's 10. 10 to the power of 2 means there are 2 zeros after the 1, so it's 100. And so on and so forth all the way to 10 to the power of whatever number you want. Here we have it up to 8, but it can obviously go to more. Now, what is the other thing that you may have never seen before is these negative numbers here. Now, you may or may not have seen them if you've dealt with integers, but if you haven't, don't worry about it. What's important, though, is that it basically tells you that we are going on the other side of the decimal, or on the right side of the decimal. And this negative sign is basically telling you that it is on the other side of the decimal. And in this case, it's just telling us that it's on one side of the decimal, it's on 2 sides of the decimal, it's on 3 sides of the decimal. And that's what the negative, for you, if you're not comfortable with negatives yet, that's what it basically tells you. So what we're going to do is we're going to practice first by expanding a number. So the number that I'm going to give you right now is 529 and 63 hundredths. So you might be familiar with the fact that this is standard form. You might be familiar with the way I said it is in literal notation. You can write it out in words. But I also want you to notice how we can write this differently. We can write this as 500 plus 20 plus 9 plus 0.6 plus 0.03. This tells us about the 500. This tells us about the 20 and 29. This is the 9s because it's the 1s. This is 0.6 or decimal 6 because this is in the tenths column. And this is 0.03 because this 3 is in the hundredths column. So all I've done was I've expanded it out into its place values. If you're comfortable with this, you may also be comfortable with the fact that I might change it a little bit. And I'm going to do, instead of 500, I'm going to do 5 times 10. Or 5 times 100, sorry. Doesn't 5 times 100 equal to 100? And I'm going to change, instead of the 20, I'm going to change it to 2 times 10 because doesn't 2 times 10 equal to 20? And I'm going to continue with this 9. I'm just going to do 9 times 1 because isn't 9 times 1 just 9? And this 0.6 here, well, if I'm looking here, the tenths is a 0.1. So I'm going to do plus 6 times 0.1. And I'm going to look down here, and I'm going to see, oh, wow, my 0.03 is in the hundredths. So I'm going to do plus 3 times 0.01 because it's in the hundredths column. So all I'm doing is I'm following this lovely powers of 10 chart, and I'm expanding that 529.63 just a little bit more. So now, let's go one step further into the actual official expanded form of our number. So what I'm going to do is I'm going to take this and see if this will work. I'm going to take this and I'm going to copy it onto another slide here. And I'm also going to add the powers of 10 chart. I'm going to make it a bit smaller here so that we can see it. There we go. And then we're going to maybe move this number up a little bit because we're going to need some space. All right, now I think we are ready to actually put this in the expanded form that we are actually looking for, which is, we're going to call this number 3, the real expanded form. So what we're going to do is we're going to look at our powers of 10 chart here, and instead of writing 100, 10, 1, 0.1, and 0.01, we're going to change this into the exponents that we are actually given up on this chart. So let's start with our 5. It's going to be 5 times 10 to the power of 2 instead of 100, plus 2 times 10 to the power of 1, because I see here that 10, this 10 here is the same thing as 10 to the power of 1. Plus, my next number is 9 times, in this case, it's going to be 10 to the power of 0. And you'll notice a bit of a pattern here, 2, 1, 0. I'm kind of going in order here. The next number in 529 and 63 hundredths is the 6, so plus 6. But what is this going to be now? 10 to the power of, if I look here, tenths, it's going to be 10 to the power of negative 1. And our last number is 3, and I'm going to do it down here, 3 times 10 to the power, this was negative 1, so this one's going to be negative 2. So now that we have this in this real expanded form, I'm just going to point out a few things that might help you out. We're going to do one more example, but let's just point a few things out. Notice how I'm going in order from from the numbers in the exponents. I'm going down 2, 1, 0, negative 1, negative 2. I'm also always starting on the left side of the number. So if we look up at the top here on the number, I'm always starting from the 5 and then I'm making my way down. So I'm basically reading the number like I would read a book. I start with the first one, then the second one, then the third one, and so on and so forth. Always, and that's the way it is in my expanded form. That might help you with the order of the exponents. Also, some students have told me that for them, this number in the exponent tells them how many numbers come after it. So it's 5 times 10 to the power of 2 because they know that there are 2 numbers coming after it before the decimal. And it's 2 times 10 to the power of 1 because there's 1 number coming after the 2 before the decimal. You do whatever you're most comfortable with and whatever helps you out. But we're going to do one more together that might be a little bit more tricky for some. So let's go to a new slide. And let me give you just a random number here off the top of my head. Let's do a big one. Let's do here 8. Oh, you can't see that. Let me get a darker color here. 8, 8, 4, 8, decimal 6, 0, 6, 5, 1. And just because I might need it, I'm going to restick my powers of 10 chart here. So I think the first part is pretty easy because we're going to start with the side on the left of the decimal. And remember what I said when we did the last slide, you're going to try your best to read this like a book. So we're going to start with the first 8 and we're going to make our way to the right. So we're going to start writing 8 times 10 to the power. Well, this is here in the 10,000ths column here, in the thousands column, I apologize, it's in the thousands column. So if I look here, thousands means 10 to the power of 3. But what also helps me out is I know that there are 3 numbers that come after it before the decimal, so it's going to be 10 to the power of 3. So this is really cool because now I've started my way, I can make my way down from 3, 2, and 1. So plus, the next number is an 8 times 10 to the power of 2. 10 to the power of 2 because it's in the hundreds column, and over here it says hundreds. And 10 to the power of 2 because I know that there's a 4 and an 8 that come after it, which tells me 10 to the power of 2 digits coming after it. Next number, plus 4 times 10 to the power of 1, because 4 is in the tens column, and tens means 10 to the power of 1. Plus 8 times 10 to the power of 0, because this is in the ones column, and anything to the power of 0 is 1. And that's it for the left side of the decimal. Now we're going to talk about the right side of the decimal, which starts with the number 6. We're going to multiply this by 10 to the power of negative 1 for a few reasons. 1, because it's in the tenths column, and anything in the tenths column is 10 to the power of negative 1. And 2, because I see here that I was at 0, and so the next one coming after it, I know, is negative 1. Now, the next number after the 6 is a bit tricky because some people are not sure whether they should put the 0 or not. In my class, I tell my students that you don't have to put the 0. You technically, in proper math, don't put the 0. But because you're starting out and you really just want to see all of your numbers in expanded form, it's easier if you do put the 0, because that way you'll remember that the next number after it is actually 10 to the power of negative 3 and not 10 to the power of negative 2. And if you want, later on, we can remove it. So I'm going to do 0 times 10 to the power of negative 2, for the reason that it is in the hundreds column, and for the reason why it's 2 places after the decimal. The next number after the 0 is another 6. And because this one was 10 to the power of negative 2, I already know that it's going to be 10 to the power of negative 3, but this second 6 here is in the thousands column, which means that it's going to be multiplied by 10 to the power of negative 3. And we can keep going. 5 times 10 to the power of negative 4 plus 1 times 10 to the power of negative 5. And this is the expanded form of this standard number that I gave you at the top here. And again, as I mentioned before, because technically we don't need to see the 0, if you wanted to at this point, now that you have it all written out, feel free to just erase the 0 part. And that's really it for expanded form. My last suggestion or tip, or don't forget, is you're always multiplying it by the power, and then you're putting a plus sign between the different powers and between the different numbers. So it's kind of like, if I were to highlight this here, this goes with this, and this goes with this, this goes with this, and so on. And we're just separating them by a plus sign. And that's it for expanded form, also known as exponential form.